In the last lesson we looked at the states of matter, and in this lesson we're going to look at what happens when a substance changes from one state to another. So we're going to start off with an imaginary substance, and it's in the solid state, and you'll see that the particles or atoms are arranged in regular rows and columns, and they're held together by strong forces, tightly packed. They're tighter packed than I've depicted here. And as we mentioned earlier, everything that has a temperature above absolute zero is moving. So all the particles are moving, and in the case of a solid, they're going to be vibrating around, okay, constantly in all directions, but they cannot change position, so they cannot move from one place to another. So to help us understand what's happening here, what we're going to do is we're going to use an analogy, and we're going to say that it's as if the particles in the solid state are prisoners in a high security prison. So it's as if the lattice represents a type of prison, so you've got a series of cells, and the prisoners are stuck inside each of those cells, and they can vibrate around inside the cell, but they can't move from one cell to another. And so what we're going to do is we're going to start heating up the substance in its solid state, okay, and as we do so, we're transmitting energy to the particles. They're going to move around with more kinetic energy, and the temperature is going to increase. So it continues increasing, they move with more energy, they vibrate around more, and eventually some of the particles are going to be moving around so much that they acquire enough energy to break out of this solid lattice. That's to say, to break out of the prison cells in our analogy. Okay, so this one escapes, yippee, and when this happens, the substance will start to change from the solid into a liquid state. That's to say, as we continue heating the solid, more and more of the particles will gain enough energy to escape from the lattice and move into the liquid state. And so we see that in the liquid state, the particles are held by weaker forces, and they are also trapped inside a type of prison. Okay, but this is a low security prison. So you can imagine that it's got a fence around the outside. Now this fence really represents what we call the surface tension. It's the surface tension which holds a droplet of water together, and you can see this visibly in a ball of mercury, that it's held together by quite strong surface forces. Okay, so these particles are able to move around freely within the liquid structure at quite high speeds. They travel faster than in the solid state because the temperature is greater, but at the moment they've not got enough energy to break through this surface tension, this low security prison that we've set up. But as we heat them more, they'll start moving around faster and faster and faster, and eventually, yippee, they start to escape, this time into the gas state. Okay, so again, this represents really the surface tension, and that's what holds the liquid together. And again, as we continue heating up this liquid, more and more particles will acquire the energy required to break through the surface into the gas state. And when the substance is in the gas state, there are large distances between the particles, and the forces of interaction are very, very weak, and the particles are effectively free. So we can say that the prisoners have broken free. Okay, now when a substance changes from a solid to a liquid, we call that melting. The process is called melting. When it changes from the liquid into the gas state, we call that evaporation. And what we're going to do now is we're going to allow the gas to cool. So we're going to remove the heat, click, remove the heat, and what the particles will now do is they lose energy and they will reform into the liquid state, and they'll continue to lose energy and eventually reform into their solid lattice. So we call this process condensation, and we call this process solidification. Now in the case of water, which is a very important substance which commonly exists in all three of these states in our everyday experience, well, water is given a particular name in each state of matter. When it's a liquid, we call it water. When it's a solid, we call it ice. And when it's a gas, we call it water vapor. So it has its own particular names. It's so important. That doesn't apply to other materials. And also the change from water to ice is often known as freezing, but really the generic name is solidification. Okay, but these really mean the same thing. And I'd also like to mention there are some materials, for example, iodine is an example, and you can see this in the practical demos section of the website, where the substance doesn't actually exist in a liquid state. So when you heat solid iodine, it goes directly from a solid into a gas, okay, like that. And when that happens, we call this sublimation. And the same word is also used in the reverse, where the substance goes from a gas back into a solid. So for example, that occurs with iodine, iodine and carbon, for example. So these don't exist in the liquid state. Right, now in the next lesson we're going to have a look at this in a little bit more detail, and we're going to look at how the temperature changes in a substance as it moves from the solid through to the liquid and into the gas state. So we're going to examine the temperature time curve for that substance as it's being heated.